Assalamu alaikum students. This is Naheed Saleh from Government College for Women, Shahra, Liaquat, Karachi. This lecture is my first lecture of a series of lectures intended for BSc final year students, Maths group and Biostatistics groups both. Let's recite dua to increase our knowledge and to ask Allah for His help. Bismillahir Rahmanir Rahim. Rabbi zidni ilma. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Amin. Summa amin. Okay, students, the syllabus for mathematics group of BSc final will be covered by the course books 3 and 4 written by Professor Shahid Jamal. These are actually the course books for you. We can use any reference book that we want. That's up to us. Biostatistics students will be continuing with the same book by Daniel, which we already have been using in the third year. The only difference between the two groups syllabus is that the biostatistics students will not be needing all the derivations that maths group would be doing here. Apart from this, any statistics book on inferential statistics can be used as a reference book. I'll try to mention names of a few books at the end of this lecture, inshallah. Now, statistics has been divided in two branches, or rather areas: descriptive statistics and inferential statistics. Descriptive statistics is whatever we studied last year in the third year of BSc, and inferential statistics would be covered this year. So let's move on to our next slide. Inferential statistics can be defined as the science of decision making under uncertainty. In life, there is no certainty about what will happen in the future, obviously, and by now we know it more than ever. But we also know that life must go on and important decisions still need to be taken. Even what to cook today, or how to get our studies done, these are the things, these are the daily routine things that involve decisions. So decision processes, this means, must be able to deal with the problems of uncertainty. Now, uncertainty creates risk, and this risk must be analyzed in order to make good decisions. Luckily, statistics has ways of measuring that risk. Whether to invest my savings in a certain project or not, there is risk involved, obviously. Whether to get my spine surgery done, a huge risk is involved. Government decided to lock the city down after careful consideration, and it was a decision that they made after a lot of planning and after going into many things. So first step, students, is always to study a situation, and then the second step is to make decisions. The statistics that we studied last year involved looking into a situation. That is, we calculated measures of central tendency to find the average situation, and then we went on to measure the variation, which gave us an idea of how things might deviate from the normal situation, or let's say from the average. So this means that first year statistics was descriptive statistics, and this year we are going to study the second part, which is how to make a decision. Let's pause for azan. Okay, students, before Azan break, we were discussing that statistics has ways of measuring risks involved in decision making. So, if we were in a proper class, I would have asked you at this moment to think of a term, a mathematical term maybe, or any idea that we may use for uncertainty. That is, what do you think would measure uncertainty? But as we are not in a proper class, so I think I should tell you how uncertainty is translated into a mathematical language. Quantitative modeling of uncertainty uses a branch of mathematics called probability. So you are all familiar with this term. We studied a whole chapter on this topic last year. So this year again we will be studying probability and its distributions in detail to help us measure uncertainty. The next chapter that we are going to start is chapter number 1, book number 3, that is all about probability and probability distribution. Book 3, chapter 1 is about continuous probability distributions. This is the book that I mentioned earlier, written by Shahid Jamal. So before we go on with the continuous probability distributions, you all must recall from third year some basic definitions that we are going to need throughout this year. So those definitions that we must know and understand are random experiment, discrete random variables, and its probability distributions. The textbook definition of a random experiment is that it is an experiment or a process for which the outcome cannot be predicted with certainty. The most simplest example of a random experiment can be considered as a single toss of a coin that may result in a head or a tail. Now, in a toss, no one knows what the outcome would be, even though we know it would be either a head or a tail. This means that the outcome cannot be predicted with surety and depends on chance. When we try to calculate Earth's gravitational force in a laboratory, every year students do that, and it comes very near to the value of 9.8 meter per second square, approximately 10. So every time this outcome is certain and sure. So now you know what is the difference between a random experiment and a scientific experiment. Let's move on to the next concept, random variable. It is a variable whose values depend on outcomes of the random experiment that I was talking about earlier. And if we have a variable and can find a probability associated with that variable, then that is a random variable, unlike a normal variable. So random variable is basically associated with the concept of the probability. Random variable there are two types of random variables, just like variables, qualitative and quantitative. Qualitative variables, as you must already know, they would explain the quality of something, and quantitative would obviously give you quantity. And this year we will be focusing for the time being on quantitative variables. So let's just give a quick recap. You can read this slide if you want to, and I would just move on to quantitative variables at the bottom. Quantitative variables again are divided into discrete variables and continuous. Discrete variables have already been discussed in detail, and so our main topic is continuous variables. Continuous variables are continuous variables are all those variables which can take on any value within a given range. So let's move on. This is again a slide that would give you the major differences between the two. So I would just move on. The last topic, a very important topic actually, the probability distribution. So what is actually a probability distribution? Remember last year we constructed frequency distributions. So frequency distribution was any table or anything that would give you some idea about the values of a variable, and there was a column that showed frequencies along with the values. So any table that gives you the values of the variable along with the frequencies, we called it a frequency distribution. So similarly, any table or any formula or any graph that gives you, that shows all the values of the random variable, and along with the values of the variable, you can tell about the probabilities associated with every single value of the variable. So that would be then a probability distribution table. Probability distribution satisfies following two conditions which are written over here. Number one is that probability of all the values, that is each and every probability must be positive, as we already know. It should be it can be 0 or greater than 0. And then again, when you sum the column of probabilities, the sum must be 1. Let's consider an example involving 3 tosses of a single coin, or one single toss of 3 coins. It's the same thing. So let's recap all our concepts with this problem. Here in this experiment, tossing of 3 coins or 3 tosses of a coin would be the random experiment, and obviously the result that we might get would be either we would get no head, that is all 3 coins would result in heads, or they might end up all tail side up. So the values of the random variable in this case would be either 0, 1, 2, 3, depending upon what we are interested in. So I have mentioned the random variable of interest as number of heads. So the values of random variable would be 0, 1, 2, 3. 0 means no head turned up, 1 means 1 head turned up, 2 means 2 coins showed heads, and 1 must be tail. The value of x as 3 means that all the 3 coins showed heads. These are all the possible values. There is no fourth option. Now constructing a probability distribution for this random variable x. The table shows, the first row shows all the values of x, that is no head, 1 head, and so on, and the last one shows the probabilities. I have calculated these probabilities. If you do not know or have forgotten how to calculate these probabilities, then I would suggest you give your book, the third year book, a revision, or maybe you can write to me and I would explain them to you in a separate lecture. Students, I have mentioned one book written by Walpole over here. There are actually many reference books out there in the market. At the moment I would just write this down because you might already have it, because of this all this situation you may not be able to get the book. So any good statistics book will do for you, especially the one with the inferential statistics topics. I have mentioned one link which I have studied myself. It's an e-book, and if you can access it, then this would be great. My next lecture would be about the same continuous probability distributions, but I would try to solve all the problems there, and then we will come to a very, very important class which would involve studying all the 4 important continuous probability distributions this year, just as we studied binomial, Poisson, hypergeometric and geometric distributions. So please do not miss these lectures, especially my students of Shahra Liaquat College. Thank you.